In this tutorial, we are going to solve some practice questions under Newton's laws of motion. So I've got a number of questions with me here. So let's start with this question. So the question is saying the floor of a railroad flat car is loaded with a loose boxes of medicine having a coefficient of static friction of 0.25 with the floor. If the train is initially moving at a speed of 48 kilometers per hour, in how short a distance can the train be stopped at a constant acceleration without causing the box to slide over the floor? Okay, so it is very important for us to understand the question. After understanding the question, we need to come up with a free body diagram. Okay, so now let's assume to say this is the rail line, or let's just say this is the road. Okay, so we're going to assume that this flat car, it was moving. Okay, here is our flat car. This flat car is moving at a constant velocity. Once something is moving with constant acceleration, in short here they are saying constant acceleration. Okay, so now we are trying to find the what? We are trying to find the distance. Okay, so initially we can see that we have the mu value to be 0.25. What else do we know? We can also see that we have the initial velocity. The initial velocity is 48 kilometers per hour. Now from here, what else do we know? We can see that they're saying that if the train is initially moving at this, in how, so for it to stop, meaning that the final velocity is going to be 0 at that point. Okay, so we assume that it started from this point all the way to this point, meaning that at the last point here the final is 0, the final velocity. The initial velocity here we have been given. Now we have to convert this velocity into meters per second. To do that, we are going to use dimension analysis. We are going to say 48 kilometers per 1 hour is going to be times in 1 kilometers. How many meters do we have? We have 1,000 meters. Again, in 1 hour, how many seconds do we have? I've got 3,300 seconds. Now we can see that kilometers and kilometers will cancel. Hour and hour will also cancel. What are we going to have? We're going to have a 48 times 1,000. Then we divide it by 3,600. I'm getting the velocity now to be 13.33 meters per second. Now we want to find the what? We want to find the the acceleration in this, the distance in this case. If we can check here, the only force which is acting in this object, we can see that we have only friction force. When the car was moving in this direction, there is a friction force which was opposing the motion. Okay, therefore we need to find the acceleration, the same constant acceleration. So we're going to say the summation of all the forces in x direction, because we have got the motion in x direction, right? So we're going to say the summation of all the forces in x direction. We're going to see that we're going to have the only force which is acting at that point is the friction force. So that friction force, since it was opposing the motion, it's going to be negative. So we're going to get that acceleration to be negative. So what are we going to do now from there? We can see that the next thing which we're going to do is we're going to say the summation of all the forces in x direction. We have got the friction force only, but this friction force is supposed to carry negative because it is opposing the motion, and remember it is decelerating, so the acceleration is going to be negative. According to 2-second law, it's going to be mass times acceleration is equal to negative mu times normal force. Normal force in this case is going to be mg, so we're going to have mass times acceleration is equal to mu times mg. We cancel the mass, we can see that acceleration is going to be negative 0.25 times 9.8. So what is 9.8 times 0.25? So I'm getting my acceleration to be negative 2.45 meters per second squared. Now that we have our acceleration, now we can find the distance. Since we don't have time, the only formula which can work is a third equation, where we're going to say the final velocity initial squared times 2a d. Remember, the final velocity is 0, the initial is 13.33 squared plus 2, acceleration is negative 2.45 times d. So we shift this to the other side, it's going to be negative 13.3 squared plus, or this is going to be equal to, then we're going to have 2 times 2.45. So this is going to give us 4.9d, which is negative. So we divide both sides by negative 4.9, even here by negative 4.9. Negative and negative will cancel. Therefore, our distance is going to be 13.33 squared. We divide it by 13.33 squared. We divide it by 4.9. So I'm getting my distance to be 36.26 meters. So this is going to be the distance now. So that is it for this question. Number 2. In a pickup game of dome shuffleboard, medical student crazed by final exams use a broom to propel a calculus book along the dome a hallway. If the 3.5 kg book is pushed from rest through a distance of 0.9 meters by a horizontal force of 25 newtons from the broom, and then has a speed of 1.6 meters per second, what is the coefficient of kinetic friction between the book and the floor? Now, to find the coefficient of friction, what we have to understand is that let's assume to say this is the floor. Now, the book was being propelled in this direction. Let's assume to say this is the book. Okay, we assume that here is our book. So if this is our book, then there is a force which is being applied. The force which was used to propel this one was 3.5 newton, or it's 25 newton, sorry. So the force is 25 newton. Then there is friction, which is opposing motion. The mass of this book is just basically 3.5 kgs. Okay, now initially we know that they are saying that it was pushed from rest, meaning from rest the initial velocity is 0, then the final velocity is the one which have been given, 1.6 meters per second. What else do we know? The distance is the distance it moved is 0.90 meters. Now the question is, we need to find the coefficient of friction. So we know that we are going to say, to find the coefficient of friction, we are going to say the summation of all the forces in x direction. Since it was moving, we are going to have acceleration in this case. We have got the applied force which is pointing toward the positive x-axis minus the friction force. Friction force always carries negative because it is opposing the motion. Okay, so in this case, since there is acceleration, we replace this with mass times acceleration. So we're going to say mass times acceleration is going to be the force minus this is going to be mu times the normal force. But we know that the normal force is mg, so we're going to say mass times acceleration is going to be force minus mu, then you have mg. Remember, our goal is to find the mu value. So what we're going to do here is I'm going to shift this to the right hand side, and then I'm going to shift everything here to the left hand side. So we're going to end up having mu times mg is going to be equal to the force. This force remains here, minus, because I'm shifting this to the right hand side, minus mass times acceleration. So we can now divide both sides. Okay, we can now divide both sides by mg. So let's rewrite it. We have force minus this. We divide it by mg, even here by mg. You can see that these two, they are going to cancel. Our mu k is going to be the force minus mass times acceleration divided by mass times g. Now this is our formula, but remember, we have everything. We have the force, which is 25, the mass we don't have acceleration. Now we have another information here which can help us to find the acceleration. So the mu k in this case, let's just put our formula here. So let's get rid of this now. We have this information here. This information can help us to find the acceleration. Okay, since we don't have time, the only formula which can help us is the third equation, this equation. Let's start now plugging in the values. The initial velocity, the final velocity is 1.6. I square it. The initial is 0. Then you have 2. We're trying to find acceleration. The distance is 0.9. Let's say. So we have 1.6 squared. If you want, you can find it in advance. Then you're going to have 0.9 times 2, which is 1.8. 1.8 times a. We divide it by 1.8, even here by 1.8. We can see that acceleration is going to be 1.6 squared divided by 1.8. So I'm getting my acceleration as 1.422 meters per second squared. Now that we have our acceleration, let's plug in the values in this formula. Mu k is going to be, the force is 25 minus the mass. We have been told that is 3.5 times the acceleration 1.422. Then we divide it by the mass, which is 3.5 times 9.8. Now let's see what we're going to have. So our mu k is going to be, we have 3.5 times 1.422 is giving me 4.977. Then 25 minus 4.977. So on top there I'm getting a 20. Then I divide this by 9.8 times 3.5. This is giving me 34.3. So our mu k is going to be 20 divided by 34.3, which is 0.58. So 0.58 is going to be my mu value. Now what we need to understand again here is this is the coefficient of friction. Coefficient of friction is always less than 1. So when you're calculating coefficient of friction, when you discover that the answer is greater than 1, just know that the answer is wrong. So the coefficient of friction always, the mu k or the mu s is always less than 1. Okay, so in this case the answer is 0.58. Okay. Number 3. A bedroom bureau for an anonymous medical doctor at the University Teaching Hospital UTH in Lusaka with a mass of 45 kg, including drawers and clothing, rest on the floor. Part A, if the coefficient of static friction between the bureau and the floor is 0.45, what is the magnitude of the minimum horizontal force that the doctor must apply to start the bureau moving? Part B, if the drawers and clothing with 17 kg mass are removed before the bureau is pushed, what is the new minimum magnitude? Okay, So now, like I said, once we come up with a flatboard diagram, this question is going to be very much easy for us. So we need first to understand the question. So we're going to to assume to say he is a patient. Okay. Now this is the combination of the clothes. Let's put clothes in white. Let's say these are clothes. Then in 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 blue, let's put to say this is a drawer. Okay, so the combination of the drawer, the patient, and the clothes is 45 kgs. That's the combination, 45. So now they're saying that when you are going to push a force here, which let's call F. Then they are saying that there is a friction which is opposing the motion. So they are saying that a minimum. They are saying that the coefficient of static friction. So static friction meaning it was not moving at all. So we are going to have Fs. So now what we are going to do here is since this object is not moving, meaning that the net force is 0 in this case, we are going to say the summation of the forces in x direction. We have got the applied force, which is pushing an object toward the positive x-axis, minus the friction force. Remember, the net force is 0. We'll replace this with 0 because we're talking about, how can you know that this is the net force is 0 here? Because we're talking about static friction. Static friction meaning an object is not moving. Static friction is a friction which is going to be there when the object is not moving. Once the object starts moving, then that static friction is going to be converted to kinetic friction. Okay, so meaning that this is going to be 0. It's going to be the friction, the force, minus this is going to be mu times the normal force. Normal force is mg. We shift this to the other side. We're going to have mu mg is equal to the force. Our goal is to find this force. We have everything. The mu value is 0.4 times the mass is 45 times 9.8. It's going to be equal to the force. So we have 0.45 times 45 times 9.8. So I'm getting my answer to be 198.45. That would be the minimum force. 198.45 newtons. So that would be the magnitude of the minimum horizontal force that the doctor must apply to start the barrel moving. As simple as that. Now, part B is saying the same thing which we have here. What if you remove the clothes and drawers? So they're saying that the combination of drawers and clothes is 17 kgs, meaning that we need just to say 45 minus 17. That is going to be the mass of the person. So 45 minus 17 is 28, meaning the mass of the person only was 28. Now what would be the minimum force required for this barrel to start moving? So we're going to do the same. Summation of the forces in x direction. We have the force minus the friction force. This net force is 0. This minus mu times the normal force. I shift this to the other side, left hand side. It's going to be mu normal force is equal to the force. Normal force is mg. It's going to be the force. The mu is the same, 0.45 times the mass. Now is 28 times we have now the g, which is 9.8, is going to be equal to the force. So the force required in this case is going to be 28 times 9.8 times 0.45. So this is giving me 123.48. That is going to be our minimum force which is required to push the what? The bureau. So that is it for question 3. So we have question 4, which is saying a slide loving Nessie slides down a certain 35-degree slide is in twice the time it would take to slide down a frictionless 35-degree slide. What is the coefficient of kinetic friction between the nest and the slide? Now, let's understand this question first. So understanding this question is going to help us to know what's happening here. So we have two things. We have got the, it's on an incline actually. So we have got this incline. Okay. So the first incline, they are saying that there is friction. Something is riding at an angle of 35 degrees. So here is an object which is riding. It's moving in this direction. So there is friction here, which is opposing the motion. And we know that on an incline, FG is the one which is pulling an object down. So this is with friction now. With friction. But there is another one which is happening here without friction. You can put it here. So there is another one which is happening without friction. The angle is the same, 35 degrees. Here is our object, but there is no friction, meaning that there is only FG which is pushing an object down. So we're going to say this is with friction. Now, the question here is saying a slide loving Nessie slide down a certain 35 degrees slide in twice the time it would take to slide down frictionless. The one without friction, meaning that let's say the time with friction is just t. Okay, or let's say this is 1 and this is 2. Okay, so let me put t1 here, meaning that the time 1. They're saying that this time has to be twice when we have what? When there is no friction, meaning that this is the same as the time for 2 is going to be the same as 2 times t1. Okay, 2 times t1, 2 times t1, because they're saying that from this point here, they're saying that a slide loving Nessie slide down a certain 35 degree slide in twice the same in twice the time it would be, or it would take the slide down a frictionless. So if there is no friction, meaning that this time times 2. So that's the equation which I have here, meaning that once I put this is going to be the same as this guy here. So meaning that these two guys are going to cover the same distance once we have this information which you have here. Now, what we need to understand again is that we need to find the acceleration. Okay, finding acceleration is going to help us. So we're going to find the acceleration for this equation here. Okay, once we find the acceleration for this one, meaning that we are going to put also once we find this acceleration, this is going to be the same acceleration which we are going to use here. Okay, because we have made this equation to be the same. So we're going to say the summation of the forces with friction. Okay, this one is supposed to be without friction. So here we don't have friction. It's supposed to be without friction. Without friction. So without friction, we can see that the summation of the forces we're going to have only Fg. Fg on an incline is mg sine theta. So we're going to replace this with mass times acceleration. Is going to be mg sine theta. Now, on an incline, whenever we're talking about the normal force, is mg cos theta. Let me just remind you. Then Fg is mg sine theta. Now here we can cancel the mass, and we can see that acceleration is going to be g sine theta. Let's see. Our g is 9.8 sine 35 degrees. And we're going to see that our acceleration is going to be 5.6 0.62 meters per second squared. That is the acceleration now. Now we are saying that at this point the distance is going to be the same. Okay, so if the distance is going to be the same, what are we going to do now from here? Okay, so now we have the acceleration for this one. What was the acceleration for the first one, for the second one? So for the second one, the summation of the forces in x direction is going to be, we have the Fg trying to pull an object down, but the friction force is opposing the motion. So we're going to have mass times acceleration is going to be equal to Fg is mg sine theta minus friction force is mu times the normal force. Normal force on an incline is mg cos theta. Now from here we can see that we can cancel the mass. I cancel this mass, I cancel this mass, I cancel this mass. We're going to see that acceleration is going to be g sine theta minus mu g cos theta. As simple as that. Now we have that. We want to find the coefficient of friction. That is our acceleration. So now let's do this. We are going to say this is the acceleration for 1. I'll put acceleration for 1. This is acceleration for 2. So let me just put it here. Acceleration for 1 is 5.62 meters per second squared. Then what of acceleration for 2? Acceleration for 2, we only have the formula, which is I'll put it here on top. Acceleration for 2 is g. I can even factor out g. I'll say, okay, g sine theta minus mu g cos theta. Now from here we can see that the distance is going to be the same, like we have said. Since we have made these two guys to be the same, meaning the distance is going to be the same. So I'm going to have two formulas. Since we have time, the formula which we're going to use in this case, we're going to use this. D is equal to V initial times T plus half at squared. Now remember, our initial velocity is 0. So this is going to be cancelled. So this is the D for 1. I'll set for 1. So I'll have half acceleration 1 T squared. Okay. So T1, this is going to be T1. I'm going to put T1 here. Okay. So this is the formula for the first one. So I'm going to say D2 or D1 is going to be equal to half A1 T squared. As simple as that. Now let's go to 2. 2, we can see that if we use the same formula, we're going to have D2 is going to be V initial times T2 plus half A2 T2 squared. Now what we're going to do here is the initial velocity is 0, started from rest. We're going to cancel this. So D2 is going to be, to make time to be the same, I'm going to say this is the same as 2 times T1 squared, meaning the time now is the same. So I can simplify this and say it's half A2, then 2, this is going to be 4 T squared. Okay. So now what I'm going to do now from here is, this is 2 squared and T1 squared. So now the time is the same. The distance, meaning D1 and D2, they are going to be the same. So what I'm going to do is, I'm going to put where there is D1 with D2. So let me just put this equation here. D2 is half. Then A2, we have 4 T1 squared. So now D1 is equal to D2. So D1, now I no longer need this. I can see that my D1 is half A1 T squared. It's going to be equal to D2 is half A2 times 4, then T1 squared. From here we can cancel the half. Then you're going to have A1 T squared. T now is the same. Okay. The T is the same, T1. Then here we also have 4 A2 T1 squared. At this point we can also cancel the time, because the time is the same. So we cancel this t, we cancel also this t. You can see that a1 is going to be equal to 4a2. Let's plug in the values. What is our a? Our a1 is 55.5.62 is going to be equal to 4. What is our a2? Our a2 is g sine theta minus minus mu g cos theta. Remember, our goal is to find the mu value. Now I can get rid of everything here. To create space, I'll remove this. Then I'm going to say I have 52, or 5.62 is going to be, I can distribute 4, which is going to give me a 4g sine theta minus 4 mu g cos theta. I can shift this to the left hand side, or I can shift this to the left hand side and then I shift this to the right hand side. So it's going to be 4 mu g cos theta is going to be equal to 4g sine theta minus 5.62. We divide everything by 4g cos theta, even here 4g cos theta. So we can see that the mu k is going to be equal to 4g sine theta minus 5.62, everything divided by 4g cos theta. Let's plug in the values, we see what we're going to have. So we can see that the mu k in this case is going to be, we have a 4 times 9.8 sine 35 minus 5.62. Down here we have 4 times 9.8 cos 35. So what will be our mu value? We get rid of this. You can see that our mu k is going to be, what is 9.8 times 4? 39.2. So 39.2 sine 35. The answer I'm finding 22.48 minus 5.62. So on top there I'm getting 16.864. Okay, let's see what we're going to have down there. We have 4.9. okay, 4.9, or we have 4 times 9.8 down there, 32.9. So 32.9 cos 35. So down here I'm getting a 26.95. So the mu k is going to be we're going to have a 16.864 divided by 26.95. So I'm getting my answer to be 0.62. That is my mu value. Okay, in this tutorial we are going to solve a question under Newton's laws of motion. So here's a question for you. A 2.5 kg medical equipment is initially at rest on a horizontal surface. A horizontal force F of magnitude 6 newtons and a vertical force P are then applied to the equipment as shown below. The coefficient of friction for the equipment and the surface are mu s is equal to 0.4 and mu k is equal to 0.25. Determine the magnitude of the friction force acting on the equipment if the magnitude of P is part A 8 newtons, B 10 newtons, and C 12 newtons. So initially they are just asking us to find the friction force. But see, we have got two things here. Two things are involved. Question 6. A radiographer, baseball player with mass M 79 kgs sliding into a second base is retarded by a friction force of magnitude 470 Newton. What is the coefficient of kinetic friction mu k between the radiographer and the ground? So here's our question 7. So the question is saying Mbhozi is a female student majoring in pharmacy at the University of Zambia, Ridgeway campus. She pushes horizontally with a force of 220 newtons on a 55 kg crate containing medical supplies to move it across a level floor. The coefficient of kinetic friction is 0.35. What is the magnitude of the friction force and the acceleration? Number 8. A coefficient of static friction between the Teflon and the crumbled eggs is about 0.04. What is the smallest angle from the horizontal that will cause the eggs to slide across the bottom of the Teflon coated skillet? In this tutorial, we are going to solve a very interesting question under Newton's laws of motion. So, here is our question. When the three blocks in the figure below are released from rest, they accelerate with the magnitude of 0.5 meters per second squared. Block 1 has mass m, block 2 has mass 2m, and block 3 has mass 2m. What is the coefficient of kinetic friction between block 2 and the table?